All right, so today we're in section 5.1, rational numbers. Okay, so the first thing we need to talk about is what is a rational number and what's an irrational number, right? So the opposite of rational is irrational. So a rational number basically is any integer, any whole number. The Venn diagram down here kind of shows us the breakdown. You don't necessarily need to write all of these words. That's not necessarily the most important part. You also need to know the opposite of rational, which is irrational. And irrational numbers do not terminate and do not repeat. Okay, so here's what I want you to write. Rational numbers are integers and whole numbers, repeating decimals, and terminating decimals. I'll say it again. Rational numbers are integers, whole numbers, repeating decimals, terminating decimals. Irrational numbers do not terminate and do not repeat. And I'll write that on the board also. Okay, so in example 1, we're identifying rational numbers. In order to write a number as rational, you can write it as what we call the quotient of two integers. That's a fancy word for write it as a fraction. How could I write the number 7 as a fraction?
1 over 7.
Not 1 over 7. 7 over 1. Done. Okay? So I take any of these values, these numbers, and I write them as fractions. All right? But now notice negative 10. We see a difference here because this is now negative. In order to write this as a quotient of two integers, it needs to either be written as negative 10 over 1 or 10 over negative 1. What we see specifically here is that the negative is attached to one of the numbers. It does not matter which one, but the negative cannot be in front of the fraction. So it can't be this, where it's in front of the fraction and not attached to anything. That would be wrong. Okay? So either one of these formats would be fine. What do you notice about the third one? It has a fraction, but it also has a whole number. So I need to change this whole mixed number into an improper fraction. I do that by multiplying the whole number by the denominator. What's 5 times 4? 20. And then I add the leftovers in my numerator. What's 20 plus 3? So 23 over 4. There are no negatives, so I would box that in as my final answer. Now on this last one, what do you notice that's different about this mixed number? It's negative. Now, you are not going to factor in the negative when you're changing it to improper. The negative just gets carried over into your improper fraction. And what I mean by that is you still multiply 3 times 2 like normal. What is 3 times 2? We're not going to count it as a negative 3. 3 times 2 is 6. 6 plus 1 is what? 7 over 2. And now we're just going to bring over my negative. So the negative does not play into converting it. Do you get that? Okay. So where can I put the negative? Can I put it out in front of the fraction?
No.
Where do I put it?
On top or bottom?
On the top or on the bottom. Either one is acceptable, but it has to be attached to one of the numbers. All right, so that's how I would write my answer as a quotient of two integers. Your first section on your homework tonight is just like this. Okay, example 2. Now I'm getting into this terminating and repeating decimal. Here are some examples. You do not have to write all these words down, okay? A terminating decimal has an end point, meaning no remainder, it just cuts off. So here's some examples. 2.3, 3.24, 14.235. I'm just making these up, but basically what they all have in common is they have an end point. They stop, okay? If I was doing long division, I wouldn't be carrying over any leftovers, all right? A repeating decimal looks like this. It's a digit or a block of digits that repeat without end. 1.333, and it keeps going, I can write this with bar notation, which number repeated? 3, so I can write a bar over it. 1.3 repeating. And I can do that for, like, let's say it was 2 numbers. Okay, so what if it was 3.252525? Now I can see a pattern. So now it's 3 and I would just say 25 with the bar notation showing which numbers repeat. Okay, so only do the bar over which numbers repeat. All right, the last one I want to show you, you got that? With the bar notation is, what if I had 5.166666? Which number repeats?
6.
Only the 6. So when you write the bar notation, you would say 5.16, but you would only put the bar over the 6. Okay? Because the 1 is not the number that repeated, only the 6. Make sense? So a little, hopefully just a little review for you on the bar notation for repeating decimals. But remember, if it's terminating or repeating, it's still rational. Okay, so if I were to give you a true or false question that said, true or false, terminating decimals are rational. That is true. Terminating decimals are rational. If I were to say repeating decimals are not rational, that's false because they are. Okay, so those are just some, like, basically some examples of like true, false. On your homework tonight, you'll have a couple questions that says, you know, something along the lines of an integer. Remember what we talked about integers? Numbers without decimals is a rational number. Is that true all the time, sometimes, or never? That an integer is a rational number. It's true all the time. There is no integer that is not rational because they're all numbers that repeat or that terminate. Okay, so just basically some different scenarios that kind of set it up to make pretty decent true and false questions. All right, so that should help you on those questions on your homework. Now we're going to do a little bit of converting. We're going to use our calculators for these instead of long division. And so I'm just going to make sure that everybody's on the same page and knows how to convert these between fractions and decimals. We're going to go back and forth today. So we're going to start from a fraction to a decimal. Sometimes it's a terminating decimal, sometimes it's a repeating decimal. We're going to look at both. So go ahead and enter 3/8 as a fraction into your calculator. You can either hit the fraction button or you can just do the division. Go 3/8 and hit enter. Does it give you 3/8?
No.
Now hit the S to D button. Hit the S to D button. Did it give you the decimal?
Yes.
Okay, so my decimal is what?
0.375.
375. Okay, so a simple conversion from a fraction to a decimal. Now do the next one, 5/11ths. So 5/11ths as a decimal is what?
0.45 repeating.
Okay, are both numbers repeating?
Yes.
So the bar goes above both numbers. Okay, so simple conversion between fraction and decimal. Now I'm going to skip over, we got to do mixed numbers. And then I'm going to skip over and go the other way before we do comparison. Okay, so now I need to write a mixed number as a decimal. The only thing you need to remember here is that the whole number is going to be in front of the decimal in your decimal value. And then the actual fraction is what is your decimal value. Well, we know that 33/100, we can just write, do we need to put that in our calculator? No, that's 33/100. We just write 0.33. Okay, and that's our value. Go ahead and do the second one, though. You're probably going to need to punch in the 2/11ths into your calculator for that one. What's it going to be?
2.18.
Wait. 4.18 repeating. There's a 4, not a 2. out front. So 4.18 repeating, and that's my final answer. All right, so we did fractions, we did mixed numbers as decimals, and now I do want to skip over to example 4. I'm going to come back to example 3. Writing decimals as fractions now. So I want to go ahead and flip real quick into the reverse. We did fractions as decimals. Now we're going to do decimals as fractions. Okay? So the way we do that is we look at the last place value in our decimal and what place value it's in. For example, in the first one, the 7 is in what place? The 10th place, so it's 7 over 10, and then I see if I can reduce it. Can I reduce 7 over 10? No, I cannot. All right? Now, on the next one, this is a value that also has a whole number. Okay, so the whole number out in front of the decimal will be what as a fraction?
Mixed number.
It'll be the mixed number. So now I have -3, and then I take the decimal part of it. The 5 is in what place? Wait, it's in the hundreds place. And yes, I would place the 5 in the numerator, and 100 goes in my denominator. But is this my final answer? I need to reduce it to -3 and 1/20. All right, try to do the last two now. What is the place value of the last digit of my decimal? And then convert. So on the third one, it's going to be -2 over 1,000. And that's -1 over 500. Okay. What do you mean? It's 2 over 1,000. The 0, you don't have to write a 0 out front. Okay, now in this one, it's 1 and 62 over 100, which reduces to 1 and 31 over 50. All right, who got both of those right? Okay, any questions? Any questions? All right, so that's it for example 4, I believe. Okay, so now let's go back to example 3. Okay, of the 50 mammal species found in Canyonlands National Park, 20 of them belong to order Rodentia. So what it wants us to do is write these into a fraction. Both of these scenarios into a fraction, and then compare. So how would I write this first sentence into a fraction? So the numerator is the part, the denominator is the whole. So which number goes in the numerator? 20. Which number goes in the denominator? 50. So there's my first fraction. Now I want you to write the second fraction for Badlands National Park. Second fraction is 24 over 54. So I can't tell which one's bigger at this point because it does not have the same denominator. Well, if I want to find the same denominator, common denominator, it's going to be a really big number. So comparing these fractions using an LCD really is just not practical, like what we did earlier in chapter 4. So what we could also do, since we just did some conversion, we can convert these fractions to decimals. That is a much simpler way of comparing them. So go ahead and convert 20 over 50 and 24 over 54 to decimals. So 20 over 50 as a decimal is what? 0.4. And 24 over 54? 0.4 repeating. Okay, so really when I'm looking at it as it is, I'm like, well, they both are 0.4, except if 0.4 terminates, what's the next digit after the 4? A 0. Okay, because it's a terminating decimal. But if it's repeating, what's the next digit after this 4? Another 4. So because that one repeats and it keeps going with 4s, it's actually bigger. So what we're going to say in our answer is this. 20 over 50 is less than 24 over 54. Or we could write it the other way. 24 over 54 is greater than 20 over 50. But either way, I'm showing which one is greater. And guys, this is my work right here. Without your decimal conversions, you will not get credit on homework, quiz, or test. right? Because it's just a 50-50 guess at that point. All right, so I need to see your work. Y'all ready to do one? All right, so now I want y'all to do one. Lucas and Samuel each had a pie. Lucas cut his pie into 6 parts and ate 2 pieces. Samuel cut his into 4 parts and ate 1 piece. Which boy ate a larger fraction of his pie? Don't find LCD. Convert these fractions to decimals and compare them. Okay, so Lucas's fraction is what? What's Lucas?
0.6.
But hold on though, the fraction is 2 over 6. And then Samuel's fraction is 1 over 4. And then when I convert it, it's 0.3 repeating and 0.25. So this one's a lot easier to see that which one is smaller, basically. 1/4, right? So 2/6 is greater than 1/4, and the evidence is in my work, okay? So there's my work showing my decimal conversion, and then I said it was greater. All right, so that really leads us into example 6, which example 6 deals with ordering numbers least to greatest. So now it's not just comparing 2 numbers, now I'm comparing a set of numbers and trying to establish which one is the smallest value and which one is the largest value and everything in between. Well, we faced this with scientific notation. If you remember, some were in scientific notation, some were in standard form. Y'all remember that? And in order to properly compare them, they all have to be in the same format. So what do you think would be easier? Fractions, and I have to find the LCD of 5 different fractions, or converting them to decimals? Definitely converting to decimals. 100%. That's a no-brainer. So what I'm going to do, and keep the same order, I'm going to convert all of these to a decimal. Negative 5 over 4 becomes negative 1.25. Then I have negative 0.2, already a decimal. Then I have 4.31. I'm not worried about putting them in order yet. I need to write them all in the same format. Negative 3.0. What about 5 over 2? What would that be as a decimal? 2.5. And then, what is that? Negative 4.3 repeating. Okay, so now they're all in decimal form, and now I can clearly see which one is the smallest. Think about it though. If it's negative, the farther it gets from negative, the larger the negative number, the smaller the value. So for the smallest, if it's negative, I'm looking for the highest value, the highest number, okay? It's negative 4.3. There's no other negative number in there that's farther away from 0. Does that make sense? Okay? So, but that's not how I'm going to write my answer, is it? Negative 13 over 3. I've got to write it in the original. And make sure that negative is attached to the top number. Okay? Now, what's the next smallest number? I can cross it out because I did that one. What's the next smallest?
Negative 3.
Negative 3, and that was in the original format. All right. Now I want you to put the rest of them in order least to greatest. All right. Then it's going to be negative 5 over 4. Negative 0.2. 2.5, but I got to write it 5 over 2. And 4.31. Okay, all back in the original format, and I'm done. Okay, so you are more than likely going to have one of those on your quiz over 5.1 to 5.4. Okay, so that's really important, and that kind of brings together several of the concepts that we learned. That's conversion, that's comparing, so that's kind of a couple examples all in one. All right, if you understand that, that's everything you need to know for section 5.1.